Okay, hello everybody. Welcome to our WT2 technical sessions 2. So 2. I'm very happy to be introducing you to our speakers today. Our very first speakers are Dhivya Srinivasan and then Rajitha Arcot. Both are from VMware. They have been working here for over 9 years and their expertise is in intrusion detection systems and firewalls. They're very critical to our system, so we do not have malware attacks, denial of service, etc. So with that, I'd like them to share with you whatever they have today. Thank you. Go ahead.
Thanks, Malini. Hi, this is Rajitha, and Dhivya and myself will be talking about Application Aware Intrusion Detection System. What is network intrusion? Network intrusion is trying to get unauthorized access to a network resources or say network databases and stealing sensitive data like say credit card information or social security information, etc. So today, network security admins have a bigger challenge to make sure that the network is safe and is having no intrusions. So intrusion detection system helps them in doing so. What is intrusion detection system? It is a device or a software application that monitors the network traffic for any malicious activity or any policy violations. It raises alerts to the security admins and they have the visibility to see whether to quarantine the workloads or if to tighten the security enclosures. There are different types of IDS. One is host-based intrusion detection system and the other one is network-based intrusion detection system. These are the most common intrusion detection system types. So coming to host-based intrusion detection system, the IDS is actually installed in the host here, and the traffic that is going in or out to the particular host is being monitored. This one is very operating system dependent, but the data that is collected is from each individual host. So the data is rich in more context information like applications that are running or processes that are running. But since this has to be installed in every host, as the data center grows and there are more workloads, it becomes a little overhead to maintain the host-based intrusion detection system. Coming with network-based intrusion detection system, here the traffic in the entire network is being monitored by this IDS system. This is operating system independent. The data that is collected here is from across all over the network. Traffic needs to be hairpinned here, and the data that is collected here doesn't have all the rich context of the individual host because it contains all the data. This is more cost effective, and it is because it is not operating system independent. Intrusion detection systems rely on signatures to detect the threats or any vulnerability exploits. Coming to the key functionality of IDS, some of the key functionalities are detection of threats. So this could be something like system intrusions, say for example, the system logs get deleted automatically, or file intrusions where you could see some malicious files in the system, or it could be network intrusions to like repeated attempts of invalid user or sudden increase in the bandwidth. The other feature functionality is to alarm or alert. The IDS should send alarms to the security admins so that they get the visibility to whether quarantine the workloads or to take the necessary actions. And the third one is compliance. IDS ensures business enterprises that their compliance is being met. It gives greater visibility to the network, and also the logs also ensure that certain compliance requirements are being met. IDS does real-time deep packet inspection using signatures to detect the threats over the firewall ports. It can be installed as a standalone, or it can be integrated with firewall. There are some certain challenges with traditional IDS. With traditional IDS, the IDS are installed on appliances behind the firewall, and IDS can be happening only between the workloads that are between the same VLAN here. So what happens is like there could be some, with the traffic hairpinning, there could be some network choke points. And the other one is because if there are more VLANs with more workloads being added, the maintenance becomes a little overhead. The other thing is this lacks context-rich data, such as what applications are running on the workloads or what processes are on the workloads. And One of the other bigger challenge is false positives and missing legitimate risks. When I say false positives, this is because IDS is notorious to provide a lot of events on the dashboard or wherever the network admin is looking at the alerts. When I say it is mostly because, say, there are certain signatures that are detected and which could affect only certain applications, but those applications might not be running on the workloads of that particular customer's data center. So network security admins have to take a deep look as to see whether it is a false positive or not and try to eliminate them. In that process, they might end up missing some legitimate risks. Also, in the traditional IDS, all the signatures that are being detected are being sent to the host for detection. This also causes overhead on the host because all the signatures are being sent. So coming to NSX distributed IDS, here, the IDS functionality is actually moved to the hypervisor. That way, IDS can be detected within traffic of workloads between the same VLAN as well as workloads within the different VLANs. So this avoids blind spots. The other thing is about curated signatures. IDS curates the signatures and passes them based on severity or CVE or say product affected, attack type, etc. And this gives the user to configure signatures based on their specific workload requirements that are in their data center. IDS engine also can get context-rich data such as what applications are running on the workloads in the data center, and also can get user details such as which user logged in, logged out, etc., and other details. Because IDS engine is able to get all these details, we are able to recommend profiles based on application-specific signatures based on the workloads that are running on the data center. User can use these recommended profiles and configure the IDS detection. That way, all the signatures are not sent to the host, and only the signatures that are pertaining to the specific applications are being sent and detected. So the security admin can also avoid seeing the false positives, and it reduces a lot of noise. So coming to the configuration and overflow. So first step is to download the signatures. The signatures can be downloaded from other third-party source, and it can be done from auto update or manual. And these signatures, as mentioned before, are curated according to the different severity, CVE, etc. The second step is to enable IDS. IDS can be enabled on a standalone host, or it can be enabled on certain specific clusters. The third step is to create profiles and roles. Profiles are where the signatures are collected. So the user can use the recommended profiles, which the IDS engine has already recommended based on the application specific workloads, or user can use their other profiles based on their requirements. The fourth one is monitoring the dashboard. Once the events are detected, all the events are sent to the IDS dashboard. These events also contain rich data as to what application was running when the event occurred, or what product version, and other user details, which could help the network security admin to give more detail about the intrusion that happened. From here on, I will hand it over to Dhivya to continue as to how IDS engine can get this context-rich data, which can help the network security admin see the detections in detail. Thank you.
Thanks, Rajitha. We saw what issues and challenges we face in IDS today, and now I will explain in detail how we are proposing to solve them. What we see here is a high-level view of the IDS system. We have the user workloads, which are the guest VMs. We then have the IDS engine, which checks the flow packets arriving from these workloads, and if there is a signature match, will alert the manager of these intrusions. We also have a guest introspection driver running on these workloads, which can provide us process or application info, and this gets sent to the manager periodically. The process info that we get from the VM has details about what processes are running and what versions of the product are installed. The manager can then use this information to check if there are any known vulnerabilities on these installed products, and proactively create profiles to catch any intrusions on these. We can also leverage the guest introspection agent running on the user workloads to get additional context information on an intrusion when it is actually detected, like which user running which process on which VM caused this intrusion. This can help the admin to better debug or troubleshoot his data center. Now moving on to the next slide, we will see how the process info is used by the manager in auto-creating a profile. What we see here is a list of apps installed on a guest VM. The host will periodically collect this information and send it to the manager. One of the applications we see here is Oracle MySQL Server running version 5.6.30, which is known to have a vulnerability. The screenshot you're seeing next to it is from the CVE website, showing additional details about the vulnerability itself, like which versions of the product are affected and what the impact of the vulnerability is. When this information is received on the manager can intelligently auto-create a profile to include signatures that have product type as MySQL to capture any intrusions on this product. There are users that are using these applications, and if a malicious user tries to exploit the vulnerability on the MySQL server, the auto-created profile on the manager is going to ensure that the intrusions don't go undetected and is immediately reported to the manager. Now we'll look at a demo of how the proposed IDS solution sits in with our current system. This is the NSX manager, and we are on the landing page. We first need to enable IDS on the host we are interested in. So once we are enabling the IDS feature on the host, we go with the default set of signatures for the demo purpose, but the user has the ability to also pull up the latest set of signatures. The next step is to create an IDS profile. So we are creating a profile called IDS profile 1 here, and we can select what signatures we would like to be included in this. So we are just picking all signatures of severity high. Once the profile is created, we need to add it into an IDS rule. So we already have a rule created, and what we would do is make sure that the rule uses this profile. Once the rule is published, we are all set to detect intrusions pertaining to signatures in this profile on the host. So this is the events page, which is basically the IDS dashboard, where we can see all the intrusions that are detected on the host and being reported to the manager. So what we are going to do here is simulate an IDS attack based on a MySQL server signature. So we're just going to use a packet capture and replay it via TCP replay. Once this is done, we'll see if the intrusion is being detected on the manager. This is on a VM that is on a host attached to the manager. So we have generated the packets. We now are refreshing the IDS dashboard to see if there are events. We don't see anything. This is because the profile that we created did not include a signature to capture this particular intrusion. But we do see that an IDS vulnerability profile has been auto-created. This is what the manager created after it received the information from the host, the information about the context and what processes and product versions are running. So we are now going to update the existing rule with this new vulnerability profile and republish the rule. So now that the rule has been republished, let's go to the VM and re-trigger the TCP replay. So we have seen that the TCP replay has been re-triggered. We'll check the events on the IDS dashboard. So we now see the intrusion being detected. And if you click on the details, it gives you additional metadata about the signature itself. Additionally, we see that the product affected is MySQL. We also report the CVE associated with this intrusion. On clicking the CVE, it takes us to the CVE website to give more details about what this vulnerability is. The dashboard also provides additional information about the user context. Right now, we don't have it displayed, but as per the context information that we get from the guest VMs, we can show what user was logged in and at what timestamp and what process was he running when this intrusion was detected. We will also know from which VM was this intrusion triggered. And all this information will help the admin on the manager to better secure his data center. So that concludes the demo portion of this presentation. We are now open for Q&A.
So there's a question in the chat that says, what is the performance penalty of IDS?
You mean when we add this additional context information?
Yeah, I mean when you enable it on the system.
So there will be some additional latency, and we set like 2 cores aside for IDS.
But is it
There will
typical
be some
to run?
CPU consumed.
But is it typical to run IDS on every packet received, or is there some kind of like random sampling or any such thing to reduce the overhead?
So one thing is the configuration of the signatures. So we are sending lesser signatures to the host, and also you can configure the rules accordingly as to which source and destination you want the IDS to be detected.
Thank you.
Okay, so another question is, how are signatures downloaded from third-party sites matched against the workloads? Are the signatures unique based on the application running on the host?
Can you come up with the question again?
How are signatures downloaded from third-party sites matched against the workloads? Are the signatures unique based on the application running on that host?
So the signatures that are being downloaded from the third-party side have a lot of data as to what applications they would be affecting, and other details as to CV scores, etc. So we parse the data and match it accordingly to what applications are running on the workloads of the data center.
So, but would multiple different third parties applications have the same signature, or are these all unique?
So as of now, we are having one third-party source, but if we plan to combine multiple third-party source, we will do that aggregation as to making sure there are no duplicate signatures and it is one signature that goes through.
Okay.
I have a question. In the context of virtual machines, the number of applications might be something on a host versus containerized applications. Typically, what's the difference? Because I know with containers, you can run maybe 1,000, but with VMs, you might run about 100. How does that affect IDS and the signatures you will launch on a host?
We currently don't support containers. It's just VMs.
Thank you.
Yeah.
Hey, I just want to remark, we have an awesome turnout. We have 50 participants on this channel.
That's great.
Thank you, Dhivya and Rajitha.
Thanks everyone for joining the
Thanks
demo.
everyone. Thank you for joining. Thanks.
So our next talk is about what happens when software meets storage. Our storage demands are rising as our incoming data is rising. So let's listen to what Leah Schoeb has to say about this. She's a senior developer and relations manager for AMD and focused on system level platform architecture for AMD storage ecosystems. She has 25 years of experience dealing with performance engineering, optimization, market positioning, benchmark evidence creation, and much more. She guides industry standards creations. So with that, I hand off to Leah. Thank you, Leah.
Thank you very much. And I'm trying to get my display right. So just let me know what you're able to see at this point.
We can see you.
Okay, so can you see the presentation yet?
Not yet.
Okay, so let's get that going.
Okay.
All right. You can see it?
Mm-hmm.
Why isn't it going into presentation mode? Okay. Are you seeing it in presentation mode?
We're seeing the notes and...
Yeah, we're seeing the presenter mode.
There
okay,
we go.
this looks right, yeah.
Okay, yay. Sorry about the challenge. I had it right the first time, but yeah.
All good.
Yeah, okay, great. Yeah, so I'm going to switch gears on you. I know you've heard a lot about what's going on with detection and security. I'm going to switch your brains into something completely different. This is a concept that's been around for a while, but we didn't quite have all the components put together to be able to really get this technology to start taking off. And so recently, there's been several startups and a couple of major companies that have been able to get this going, which is computational storage. This is something that there's a lot of use cases nowadays that take advantage of this. And I'll show you some of those use cases in a few minutes after I tell you what it is. So what it allows us to do is take compute services and get them tightly coupled with storage. There's a lot of data intensive types of applications that really need to be close to the storage in order to be able to do complex calculations or video rendering or even gaming. It's an application that's really important for today's type of computing, and to be able to offload a lot of that data intensive type of activity off of the host and onto a device like computational storage so that you get cycles back from the host to be able to do other things. The nice thing about computational storage is that it's not a replacement for the storage you have today. It's actually a complement. So the storage hierarchy that you have today, you keep that, that's not a problem. This just adds to the pyramid. And this gives you a chance to be able to relieve some compute off of managing storage, data intensive applications, those types of things. So to get to actually what it is, it's a device here. It's a storage device. It looks very similar to what you would see with an NVDIMM or an NVMe SSD drive. Very similar, but the difference is right here, you have yourself a processor. It could be an ARM processor, it could be a GPU, it could be several types of processors in here. These processors can actually, with a little bit of communication from the host CPU, be able to take work on and move some of that work off of what you have happening on the host, whether it's a client or a server. It's able to be able to handle a lot of intelligent work. Company called NGD has done a lot of work in this area. This is their solution. They have set it up with an ARM processor so that you can run a full operating system on there. You can run Linux, you can run Windows, you can have a whole Hadoop operating on there. You can have you know, an in-memory database. It's up to you on what you want to have running on this little mini environment. So it's a pretty powerful environment. It uses standard NVMe protocols over PCIe, which is very nice because then you don't have to have special protocols. You do have to have some form of API interface to be able to communicate at some point between the processors, but outside of that, everything's pretty standard. And just to show you a basic architecture, you know, let's say we have a client system and a client OS. That OS would have some APIs that be able to communicate with the application, the chosen application that you have. And some of that information may get offloaded over here to computational storage, and it gets put into the controller via NVMe protocol over PCIe, as I said earlier. And that's where it gets taken care of. So if you have something that's data intensive, you know, or you have some rendering calculations that have to be done, it takes care of everything and then sends the answer back to the host processor. And in the meantime, the host processor can go take care of other applications or other activities that you have going on, which is kind of nice. These are some various instances and architectures that are out there today from various companies that are designing computational storage that gives you a chance to see You know, there isn't just one way to design this. There are several ways to design this. Most folks, you know, use an FPGA to help out in this type of architecture. There are a couple of architectures that don't. It goes, you know, straight to using a CPU with some DRAM. So there's some various options here out there on the market today that can be used. There are two fundamental constructs that you find with computational storage. You have the devices themselves, you have the hardware, and of course you have to have the software. So you have your services, which usually carries an API type of protocol, which is being developed by standards bodies today. And I'll talk about that standards body that's putting together those types of designs and direction. Here's one where we talk about the actual devices themselves. So you can see in a overall, let's say, you know, data center type of infrastructure, where does computational storage sit? How does it get used? And a lot of folks are, you know, today use PCIe. There's talk of using NVMe over fabrics. So that's another thing that we'll be able to do, is in the future be able to use a networked type of protocol so that you can widen the amount of capacity that you use in your type of environment. Like if you're talking about, let's say, an HPC type of environment or a very large data set type of environment, you're going to want to be able to put that on a network or some type of fabric so that you have access to not just terabytes, but petabytes of data. So this is something that's really important. Also, when we look at these devices, when we look a little closer to these devices, we find that we have our management, we have our I/O protocol, we have our storage, but we also have our computational processors here. And these processors here have special communication. Over time, we may be able to add more than one processor if we'd like to a computational storage device, which would be nice, but that's something that's looking in the future as a concept. I think I showed that one already. Am I in a loop? I am in a loop. Interesting. So I'm going to get out of this and we're going to get out of the loop, and I'm going to present again so that we are no longer in the loop. Okay, does that work for everybody? All right.
Yes.
Okay, great. So when we have a fixed computational storage service, this is the software. It is something that has to be well-defined, and it's something that has to be consumable by the host agent. So when you talk about putting APIs onto a host, you know, you need to make sure that it is at least OS aware or even application aware of these APIs in order to be able to use them. So that is one of the reasons why this group has pulled in the major operating system and major application companies to be able to work with this. You know, for example, with Oracle and Hadoop and with Microsoft and Red Hat. All of them have a say in what's going on here to make sure that we have consistent communication between the main host and the storage. And also programmable services, because you may want to do something that's unique that's not part of the standard APIs. You have a specialized application, a scientific application. You want to be able to add services. So there's a framework put in place so that you can add custom services as you need to. Let's talk about some of the use cases that we have. One of the big use cases that we've seen has been with Hadoop. We've seen a lot of performance efficiencies and a lot of a host CPU being able to be used for other things because we've been able to get this type of performance just off of the computational storage itself. So our throughput is a lot higher. As you can see here, it's over double. Your total cost of ownership, because of the way this is designed, is lowered by at least 30%. And so your overall CPU efficiency, you gain about 25% of your host CPU back because you allow somebody else to do this. Another area is containers. You can put a whole container environment on the computational storage CPU. It can handle that. And so you can deploy containers within your storage and not have to use the host CPU to do that. And it allows for real-time processing, and it actually accelerates parallelism with your storage. Another area, which is the most common one that's been measured, is compression and decompression. Being able to offload these activities that you really don't need host CPU to process these. You could actually offload these to computational storage. You'll be able to use different types of databases for this. You can also, if you're using it as a normal function for your storage, you know, it is a data service for your storage. It is something that can also be handled this way right on your computational storage. And large data sets. Seagate is looking at what to do with NVMe over Fabric to be able to handle very large data sets. And I do have to say AMD is also looking at this with a couple of other storage companies to develop what can we do in a GPU-based environment. So this is something very new and unique for scientific environments and also for media and entertainment as well, in what they do in post-production, those types of things with very large data sets and video. 8K video blows up very, very large. And so being able to use it in those types of environments is really important. So those are areas that we're taking a look at. So who's doing all this work? We have all this work going on. Who's doing all this work? Well, under the Storage Networking Industry Association, we have a technical work group. It's called Computational Storage, of course. Right now we have 43 companies that are participating, and that's growing. We have almost 200 representatives that work on various research activities and developing new ideas for products. A lot of these companies here have pulled together. Some of them are competitors that have come together to work together. You know, we work together with ARM as well as working together with our partners. So there's a lot of synergy going on around bringing computational storage to market as something that's mainstream. We have a main focus and a direction. Our initial focus has been on definition, defining what is computational storage. And so making sure that we have a uniformed industry standard around what does that mean and what does that scope mean, so that as we design and develop new products and new architectures to use these products, we're all doing it on the same page, that we're not trying to do this in a vacuum. And so our overall charter, we have been looking at requirements, industry level requirements, making sure that we are using standardized protocols and interfaces so that we're not reinventing the wheel and have yet another protocol on the market. I know nobody wants another protocol on the market. We've got too many of them to deal with. So we want to make sure that we're aligned. Make sure that we're also aligned with the software companies as well as the hardware companies that are building these devices. We have to work together in unison. So we have initiatives around that to make sure that we're working at an industry level to bring this type of technology forward. So that's just a glimpse into computational storage. If you have any more questions, you're more than willing to look into it. You can check it out on SNIA.org. or you can send me an email and we can have a chat about it. If you want to join and get involved with SNIA or with computational storage, please reach out, let me know. We need plenty of hands, so we'd love to have you. Thank you.
So we have a couple questions in the chat or in the Q&A.
Okay.
So for somebody who is completely new to the storage industry, what are some recommendations for ramping up to speed?
I think the best place to start actually is on the SNIA.org website. There are a lot of basic tutorials there that talk about what is storage architecture, why is storage important, why is it the center of the universe, is my personal favorite. But it actually breaks down and goes through the basics of not only just the basic storage technology, but the technologies that are out there, because now we have a wide variety of storage, from HDDs to SSDs to NVDIMMs to static memory. There's all kinds out there, and instead of just a disk drive that sits in your laptop. So I would start there. I think we've done a great job with education there. There's plenty of videos, lots of presentations, lots of research that you can read once you get that basic understanding.
Okay, so another question is, how does this differ from self-encrypting drives in terms of cost and heat? And assuming that we will want to reprogram the compute attached to the storage, a different path for different data. So are you exploring orchestration of software attached to storage?
That is something that we have not only explored as far as orchestration with storage. There's been a lot of implementations around it, especially around cloud initiatives. There has been some actual architectural documents that you can get off of SNIA.org. They're software-defined storage architectures, awful, software-defined infrastructures. All of that. There's been papers written. There has been presentations, and you can find that on that site as well. As far as self-encrypting drives, my understanding is that the work that those drives do, the use cases of those are somewhat limited, because they are there really for security and protection and capacity optimization types of areas. With computational storage, you can run more application-like things on it. So basically, it's kind of a bonus CPU for you that you can run anything you want. You can load up an operating system, run a simplified VMware environment on it, or you can run a whole container environment, a whole Hadoop setup. And from what I understand on self-encrypting drives, it doesn't necessarily have as many use cases as computational storage, even though they do have some overlap around some use cases.
So I have a question. So this it's sort of the opposite of a GPU, right? Where the GPU is the computation and then you move the data in and out, whereas you have the data and then you add the computation. So how is the performance compared between these two, methodologies, and in general, what's the computational performance of these systems?
So the computational performance is actually based off of a shortened data path. So being able to bring compute closer to storage, you shorten that data path, and when you shorten that data path, you can get much higher performance. One of the use cases that I showed upwards of over twice the performance by just shortening the data path alone. So you not only get to shorten that data path, but you're also freeing up CPU cycles on the main host system. So applications that are purely running from the host system, they actually get some of those compute cycles back as well. And depending on the application, you could see an increase of performance there as well. Another thing, you bring up GPUs. One thing I know at AMD that we talk about looking at is, how do we bring compute and storage closer together? And so, that's something that we're exploring. And so if this is an idea, this is something that could actually allow us to do this in a different way, or even put a GPU actually on computational storage, we'll see what happens, but it's something that we're just exploring right now.
Yeah, I mean, it's a similar concept to a GPU. You bring the compute and the
Mhm.
storage close together. So it's just a different way of looking at it.
Right. And so, so now we're looking at, well, how can we get them even closer together in the GPU based type of architecture? Yes.
Okay.
So would this be kind of along the lines of smart NICs? There you've brought the smartness into the network interface card, and here you've brought the smartness into the storage kind of thing.
Correct. Yeah.
Thank you.
Anything else?
I don't think there's any more questions, so we could move on to the next talk. Thank you, Leah.
Thank you.
Thank you. Okay, so that brings us to our next speaker, Rashim Mogha. She's the founder of eWOW, and she will be talking to us about how to outsource the mundane, build a digital workplace. She's been dealing with things like robotic process automation, and she brings in years of experience as an influencer, thought leader, an author, evangelist, and a tech leader. She has worked at companies such as Oracle, Amazon, VMware, etc. So with that, I hand it off to Rashim. Thank you.
Thank you so much, Malini. Let me just make sure that I can share my screen and we can get started. Okay, making sure that you can see my screen.
We can see it.
Okay, hello everybody, how is it going? I am sure it must be a long day sitting in front of computer today and listening to all the exciting talk that's happening. This is my third year returning to Women Transforming Technology as a speaker, and every time is exciting, although this is the first time that we are doing things virtually. As Malini mentioned, I am Rashim Mogha. I'm the founder of Empowered Women of the World initiative, but I'm also head of education products at Automation Anywhere. And today we are going to talk about digital workforce. Now, before we start there, I just wanted to walk you through my journey because, Women Transforming Technology is not just about technical aspect of things. It's also about bringing our whole self to work. And it's acknowledging that we are more than just a woman in technology or a woman in cloud or a woman in robotics. This is my journey. Normally when I get introduced as an author or as an influencer or a winner of awards, one thing that's typically skipped in that introduction is essentially the fact that I'm a woman of color. And I actually have dealt through a lot of a lot of biases in my journey. I've dealt with imposter syndrome. I've been passed over for promotion multiple times. And as I go and talk about it in conferences and to other women leaders, I realize that it's not just my story. It's the story is common throughout the women leaders. So as I was looking through where I wanted to take my career after cloud computing, and as I looked through robotic process automation as an industry, one thing that really appealed to me was how robotic process automation actually allowed you to outsource the mundane and to be able to nurture your creative side, or the side that where you could be your holistic self. Like, I like to write, I like to I like to do a podcast, I like to help and sponsor other women leaders, and necessarily do not like to approve expense reports that come my way more often than not. And how could I how could I automate some part of it and outsource some part of those things that I did not enjoy maybe that much as part of my job, and make some more time to really connect with my customers, to be able to build solutions that were real world solutions. And that's where robotic process automation comes into play. So today we're going to talk about robotic process automation. We are going to understand the difference between traditional automation and robotic process automation. We're also going to talk about the future of work and the concept of the digital workforce. Then, then we're going to identify some use cases for RPA, because that's really important. Because, we know about the technology, but unless we know how we can apply that technology into our day-to-day life, I don't think there is meaning to technology. And then I will leave you with some resources in terms of how to upskill yourself for jobs of future. So we'll get started. And I'll start with a question for everybody. Can you please raise your hands and let me know how many of you have heard about robotic process automation, or worked with it, or have any idea around that? And I'm quickly going to monitor. Thank you, Priya, Anushri, Sharon, Kathy. Okay, so quite a few people who actually know about robotic process automation. That's awesome. So robotic process automation is all about creating and enabling basically tools to create your own software bots that you can use to automate your business processes. Now, I'm a speaker, I'm an evangelist, and I talk a lot about various topics on leadership and technology. But a side effect to that is that there are a lot of expense reports that come my way, and the expense reports that I have to put into the system, and that is not something that I really enjoy. So, so if I could automate one thing, that would probably be the thing that I would like to apply to automate. I was at Boston speaking about robotic process automation, and I asked the women leaders over there, what would you like to automate? And I was surprised with the answer. I had never thought that so many women actually wanted meal prep to be automated. So there you go. There's another use case for you if you start experimenting with robotic process automation. But essentially what you are doing is you're creating bots, software bots that perform the tasks that you assign them, and then you can control it. Robotic process automation actually dramatically reduces the operating costs. It scales on demand, so it increases business agility. And then business users actually get an opportunity to build and deploy RPA bots in the matter of weeks. And then you can see the ROI in a matter of days, which is really great. But automation as such is not new in the industry. Automation has been around for about 20 years. And the reality is that very few businesses have actually leveraged automation. And the reason behind that is that essentially and traditionally, automation has been focused very much around developers. The automation solutions have been focused very much around developers. And developers essentially contribute about 20% when it comes to, if you look at all the big enterprises combined, that's the amount of developers that exist. So basically, with giving that power of automation to 20% of developers did not help us in a big way, because we were not giving the power back to the business users to be able to create robotic process automation tools. So essentially what you do is, this is what I talked about 80% of the population who is everybody else. Now, then many times when, and I was confused around it too, like what is the difference between robotic process automation and traditional automation? The difference is essentially, when RPA bots work, they work at the UI level and they interact with systems just like humans would. Right? You are on a web page, you're interacting with different buttons, you're interacting with different fields. That's how RPA works. it's system agnostic, which basically means that they can work across different application types. And then RPA enables businesses to take action quickly, and they mimic the role of an agent, right? It's scalable and it can be easily integrated with the existing systems, and it can be implemented quickly, as opposed to traditional automation systems where you have to maybe go at an infrastructure or a platform layer to implement them. So what do you traditionally do in your work life, right? You do certain things, you think about certain things, you analyze certain things, and then you go on a break and have a coffee. But if you look at the digital workforce or a bot assistant that we are going to talk about, you basically, when you look at Automation Anywhere's product line, there's enterprise RPA, which is basically doing all the doing work. Then there is IQ Bot, which is thinking and uses the concept of machine learning and AI to bring in that aspect. And then analyzation happens with Bot Insight. And then together they come together, and that is the digital workforce that we are talking about. So one of the other key reasons why automation is hard for people is not because they cannot create bots, but it's because it's hard to identify processes that can be automated, right? I know that different processes that I would like to automate, but how do they all work together? In an enterprise environment, it's really, really important when you start looking at processes that it integrates with the digital transformation journey of an organization. So that's why earlier this year, Automation Anywhere actually launched Discovery Bot, which basically allows you to use AI to discover processes and then automatically create bots. So basically, imagine that you could do your discovery based on the actions that you are taking to complete a process. Then you can prioritize the automation opportunities based on the ROI, and then automatically create the bots. So it kind of goes in the full circle, helping you with discovery, helping you put together a use case based on ROI to be able to put this together and then be able to create bots. So how does this work? Basically, when you capture, you're discovering the process automatically, then it maps on and helps you visualize the process flow. You can identify automation opportunities because you've done it once. There's repeatable processes that can be identified. It helps you prioritize and then generate bots automatically, and then deploy them also so that you can review and optimize these deployed bots. Now, this is all great. We can create bots, we can deploy them, but what are the typical use cases? If you look at insurance, claims processing and administration, a big use case, right? How do you take all that information that comes in claims, sometimes in emails, sometimes via pictures, and put it together and help with the claim processing? Then also report automation, prioritizing and assigning claims, right? How to determine which claims are important, and then also data integration and billing. Then when you look at banking, verification, knowing your customer is such an important use case, right? And it was not really until I delved into this process that I realized that this is one of the biggest time consuming pieces in the banking industry, to be able to ensure that people are who they are before going into transactions. Bank reconciliation is another piece, compliance processing, loan processing, customer account management. But when you look at healthcare, inventory management is such a big piece, forms processing. I did not realize how manual some of the processes were when it came to healthcare, and systems not speaking to each other, and different laws and compliance issues that were there that had to be addressed. Digital invoice generation, global contracting systems, and again, data collection. When it comes to shipping, corporate billing and reports, email triage, credit underwriting, sales order processing, and paper mill reporting. Those are some important use cases as well. And then, this whole concept of, do you really need to create bots to be able to use them? Early on, last year I was at Women Transforming Technology, and I talked about Alexa skills and how to build Alexa skills. And love the fact that Amazon has actually provided templates that you can use to build on to Alexa skills. Think of Bot Store as your Alexa store or your app store that's available. And what you can do is you can leverage the bots that already exist and deploy them. So you don't even need to create the bots to be able to use them. And what it does is it basically turbocharges automation. You can create bots and plug in wherever there are gaps with the existing bots, and your entire use case is automated. That's amazing. I want to talk about one specific bot in particular, which is Google Cloud IT Admin Bot, Digital Worker. When I was at Amazon leading a team of training and certification experts who used to spend a lot of their time spinning up VMs, right? Or writing CloudFormation templates. Imagine that if they had this bot, which would be able to just spin up their infrastructure or VMs, 40% of their time could have been saved by having this bot in place. So, we are living in unprecedented times. We are all learning how to work in a different environment given the pandemic. And one of the things that I really want to focus on is how bots have really helped in the discovery of new vaccines and the process that's going on to discover a new vaccine or a solution to be able to help us fight this pandemic. If you really start looking at it in terms of healthcare, there's a discovery aspect where bots are helping, which is identifying the root cause, pulling all the data together and analyzing it to be able to see what the root cause can be. Discover suitable drug candidates, again, pulling all the data together. When you look at clinical and regulatory aspects, one of the key aspects is new drug administration submission and documentation that you have to do with FDA if you come across or if you have a drug that you think can possibly help. That takes a lot of manual effort, and with bots you can do it so quickly. And when that happens, it changes how you're going to impact the lives of so many people across the world. Similarly, when you look at the operations piece or patient health data, imagine if you had to wait 2 to 3 days to reconcile all the data. Your data would be obsolete even before doctors could use it. So with bots in place, it can collate all that data together, present it to you within minutes, and you always are working with the current data set. There are many, many companies across the world, be it healthcare, be it airlines, be it banks, that are actually using bots today and robotic process automation to create solutions for COVID-19. So then the question becomes, this is all good. We have heard about the use case. We now understand what RPA is all about and how it can help us create solutions that can be used to outsource the mundane and focus on the creative side of things. But how do we get started? I would like to invite you to university.automationanywhere.com and start your RPA journey. We have over 60 titles in 7 different languages available to you right now to get started. All our courses that are e-learning courses are available for free for anybody. You can also take our micro-learning courses, which are about 5 minutes long to get acquainted with the basic concepts of RPA. And for those who want to, brag a little bit, put your credibility out and test how good you are at robotic process automation, I invite you to take our advanced and master certification. So with that, I would share some links with you as well, and I'm open to any questions.
So we have a question in the Q&A. How easy is it to adapt the bots to user interface changes? Do we need to educate the bots again?
So essentially what bot does is, that's a very good question. It's based on the UI elements. So when UI changes happen, you basically need to make sure that the bots actually work with the UI changes. If they don't, you can always go back and recapture those bots. It's not recreating the bots, it's updating those bots as well, and you're good to go.
Okay, thank you.
And then also, if the underlying properties of those UI changes don't change, then you don't need to even update the bots. Any other questions that we have? Okay, if not, over to you, Malini.
Thank you, everyone. We had a wonderful session, and with that, we close WT2 technical session 2. Thank you so much, everyone. Thank you, Leah, Rajitha, Dhivya, and Karen for handling all the questions, and Rashim. Bye-bye, everyone.
Thank you. Bye-bye.
Thank you.